Good morning, everyone. So in the last class, you have studied regarding cantilever slab, right? And you have designed. So today you are going to design the one-way slab. So before starting with one-way slab, what do you mean by one-way slab? Dilip?
Ly by LD is less than
Yes, Chandana? Ly by?
Ly by Lx is less than 2, sir.
Less than 2 or greater than 2?
Greater
Greater than 2.
Yes. If the longest span by the shortest span is greater than 2, that is known as one-way slab. What about two-way slab?
Less than or equal to 2, sir.
Right, less than or equal to 2. Okay, so now I'm going to show the problem. Just a minute. Are you able to see the slide?
Yes, sir.
Okay, so take down design of one-way slab. Take down the question. A simply supported floor slab measures 3 meter into 7 meter. It is subjected to floor finish of 1 kilonewton per meter square, ceiling plaster of 0.3 kilonewton per meter square, and partition wall load of 1 kilonewton per meter square. The live load on the floor is 3 kilonewton per meter square. Full stop. Design the slab using Fe415 steel. Full stop. Sketch the reinforcement details. Full stop. The slab is located in moderate exposure condition and requires fire resistance of 1 hour. Use appropriate grade, load, and cover of reinforcement. Have you taken the question?
Writing, sir.
Okay. Take it. Okay. Have you taken the question? So what are the given data here?
Sir, live load.
Live load is given. Then live load is 3 kilonewton per meter square. Then given the dimensions, slab dimension 3 meter into 7 meter. Then Fi is given.
Plastering, sir.
F5.
Okay, ceiling plaster 0.3 kilonewton per meter square. Then what about Fy? Fy. Fy is given.
Yes, sir. 450.
No, sir.
No, sir.
Fy is not given.
Sir, 415. FT 415 steel.
Fi is 415 Newton per mm square. And what about FCK, grade of concrete?
Use appropriate concrete. You have to use M2.
So here they have not given the grade of concrete. So if this type of condition will come means you have to consider M20 grade. Minimum grade is M20. Okay. Take down. Given the size of slab 3 meter into 7 meter. Floor finish 1 kilonewton per meter square. Ceiling plaster 0.3 kilonewton per meter square. Partition wall load 1 kilonewton per meter square. Live load on the floor 3 kilonewton per meter square. Grade of steel Fi is equal to 415 Newton per Newton per mm square. Grade of concrete, that is FCK 20 Newton per mm square. And bearing, here you are going to assume 300 mm. Either you can assume 230 or 300 mm. Okay. Any doubt in taking the details? Any doubt in the given data?
No, sir.
Okay. So first you have to check whether it is a one-way slab or two-way slab. Okay. Even to set like it is design of one-way slab, first you check whether it is one-way slab or two-way slab. How you are going to check? Ankit?
So the dimensions of the slab are given, sir.
Okay, slabs are given. So how you are going to check whether it is a one-way slab or two-way slab?
Sir, we had to divide the longer span by the smaller span, shorter span. 7 divided by 3.
Good. So take down. Ly by Lx is equal to 7 by 3, which is equal to 2.33, right? So which is greater than 2. Okay. Therefore, the slab is designed as one-way slab. Okay. Next, thickness of slab. As per the IS 456-2000, page number 55. Effective depth D is equal to effective span divided by 20 into MF. MF is nothing but modification factor. Okay. All of you have studied the procedure which I have sent day before yesterday. Hello. Okay. So Fi, it is given 415 Newton per mm square, and here you are going to assume 0.4% steel, because you have the range for the steel 415. You have to take from 0.25 to 0.4. Here I have considered 0.4%, and referring the figure 4 from IS 456-2000, you have to calculate the KT value. So for Fs, you have to consider 240 Newton per mm square for the grade 415 as per the codal provision. Okay. So now calculate the effective depth. So effective depth is equal to 3300 divided by 20 into 1.3. So how it is 3300?
So bearing 300 mm.
Bearing is 300 mm. So why you are taking 3? Why not 7? Even this type of question will arise, right? See, feel free to ask doubts. Please interact with me. Otherwise, it is very difficult to make you understand. Also, it is very difficult in future. See, if you have any network issues, better you come to college. Okay, you will get internet here. College will provide the internet. You can utilize that one. But please interact with me. Chandana,
Sir,
why not 7? Why here 3 we have considered? I think diploma people can answer these things because you people have studied, right?
yes, sir.
Hmm.
IS code, according to IS code, we can provide only from 230 to 300.
Okay, that is right. You are telling regarding the bearing. I agree. What about the span? Why have considered here 3? Why not 7? I have taken 7,
Sir,
no? Yeah, tell me.
span is 3000, sir, and we have to take half of the bearing.
Okay, that is right. I will agree. Why not 7? Even 7 is also a span, right? Why you are
Yes, sir.
considered shorter span? Why not longer span?
So we should always consider the shortest span, sir.
Yes, right. Why? What you people are saying it is right. Okay, I want the reason for that. Without reason, can they provide like shorter span? Some reason will be there. Even this thing I interacted with you in the last class. Even this type of question they will ask even in any of the competitive exams or any of the interviews.
Sir, main reinforcement is provided along the shorter span only.
Yes, good colleague. Okay, understood everyone. So because we are going to provide the main reinforcement along the shorter span, that is why we are going to consider this. Is it clear for everyone? Okay.
Yes, sir.
Okay. So just calculate how much you will get. Are you getting 126.92?
Yes, sir.
Okay. So next, nominal cover as per the clause 26.4, page number 46. Even this I have discussed in with you in this one, design of beams, right? Moderate exposure and 1 hour fire resistance. This type of problem we have solved, isn't it?
Yes, sir.
Okay, so here for moderate exposure, you can refer the code book. So for moderate exposure, we are going to consider 30 mm. Okay, and for 1 hour fire resistance, we are going to consider 20 mm as per the coded provision. So when we are going to consider the nominal cover, we are going to take the maximum of above two values, that is 30 and 20. So the maximum is 30 mm. So we are going to consider 30 mm. Okay, understood. Next, overall depth D is equal to effective depth plus the clear cover plus half of the dia. So how much you are getting?
Sir, 161.92.
Okay. So you'll get 161.92. So you can just round up to 180 mm. Okay, or you can keep as it is, not an issue. Okay, or you can keep 170 mm. Okay, is there any doubt?
No, sir.
Okay, so next, take down effective depth. Effective depth provided is equal to 180 minus 30 minus 10 by 2. That is, what is 10? Reinforcement. Okay, main reinforcement dia. So you will get 145 mm. Okay. Next, effective span. Effective span is least of the following. As I said, so the first condition is center to center distance between the bearing 3.3 you will get, and the second condition is clear span plus effective depth. So clear span is 3 meter and effective depth, as you know, it is 145, nothing but 0.145. So you'll get 3.145. So among these two, you have to take the least. So the least is 3.145. So you have to consider the effective span as L effective is 3.145 meter. Is it clear?
Yes, sir.
Okay, after taking effective span, what is the next step? Load calculation, isn't it? So load calculation. So first one is the self height of slab. So how it is, the point is 0.18?
The previous slide, sir, please.
Yes.
The previous slide, sir.
Previous slide, sir.
Okay. If I'm going fast, let me know. I'll slow down. Finished?
Yes, sir.
Okay. So next, load calculation. So self height of slab. So to calculate a self height of slab, what you need? The slab, this one dimension, right? That is, you have D is 0, that is 180 mm, right? So 180 into 25 is the grade of concrete.
Density form.
Okay, so you'll get 4.5 kilonewton per meter square. Okay, next is live load. It is given in the question 3 kilonewton per meter square. Floor finish 1 kilonewton per meter square. Ceiling plastering 0.3 kilonewton per meter square. Partition load 1 kilonewton per meter square. These data are given in question, isn't it?
Yes, sir.
Okay, so calculate the total load. Okay, 9.8 kilonewton per meter square. So this one you have to convert to factored load. Okay, so you'll get 14.7 kilonewton per meter square. So it is just round up to 15 kilonewton per meter square. Why you are going to convert always factored? Why not the working load? Any particular reason is there? Hello. Hello. Are you able to hear?
Yes, sir.
So why?
Exact load, sir.
Yes, Geeta?
Sir, during the sir in finding W, we will find the exact load, sir, which
No,
is acting on the slab.
no, not exactly. Khalid?
Sir, because we are dealing with limit state design method.
Yes, good. So you're dealing with
Very
limit
factor of-
state method and yeah, Khalid, tell me.
So nothing, sir.
Okay. So you're designing with respect to limit state method, not with respect to working stress method. If you are designing with working stress method, you would have taken direct value, that is W is 9.8. So now you are designing with respect to limit state method. So you are using 1.5 factor of safety. Okay. Next, factored moment. Factored moment. So what is the formula? Mu WL square by 2, right?
8, sir.
8.
8. 2, no?
No,
Because
sir.
it is simply supported, sir.
Okay. When you are going to use WL square by 2?
For
Sir, when
cantilevers.
cantilever.
Okay, good. So here it is simply supported beam. So you are going to use WL square by 8. Okay. So now substitute the value and calculate mu.
Five point 8.9.
5 point. 5.8.
5.89, sir.
How much? Check.
18.17.
Okay. Someone got 5 point something. Sachin, tell me.
18.54.
18.17.
Okay. So we'll get 18.54 or 55. Okay. Kilonewton meter. Okay. Next, take down. Check for effective depth. Check for effective depth. So here you have to consider the section is designed as balanced section. That is mu is equal to mu limit. So you have a formula that is mu is equal to 0.138 FCK BD square for FE 415. So it is just rearranged to calculate the D required. Okay. So how much you are getting D required? Calculate. And here you have to keep in terms of 10 power 6 mu. Okay. That is 18.55 into 10 power 6 Newton mm you will get. Okay. So here while substituting mu value you have to consider 18.55 into 10 power 6. What would be? B is how much? B in question also it is
3.
not given.
3 meter.
3. No.
1000.
How much, Chetan? Is it 1000 or 7000 or 3000?
7,000, sir.
7000. Are you dealing with length or depth? Effective depth means, are you dealing with the length or depth? You're dealing with the depth, right? So you just compare with the previous problem. Always you have to consider, while designing for slab, you have to consider B per meter. Okay, that is you are going to consider as 1000 mm. Is that clear? Any
Yes,
doubt?
sir.
Yes.
Is there any doubt?
No, sir.
Okay. So how much you are getting? D required? So the grade of concrete FCK is 20, okay, and B is 1000, and MU is 18.55 into 10 power 6.
81.98, sir.
81.98.
Okay, nothing but 82, right?
Yes, sir.
Okay, which is less than, which you are considered 145. Correct? So below that, take down. Hence, save. Hence, save. Okay. Or
Yes.
next, take down. Area of reinforcement. Area of reinforcement. So in bracket you can take main reinforcement. Area of main reinforcement as per IS 456-2000, page number 96. So you have formula, that is mu is equal to 0.87 FIASTD into 1 minus FIASTD divided by FCK BD. So you know all the values, so substitute and calculate mu, sorry, AST. How much is AST?
This 38 mm square, sir.
How much?
374.38 mm square.
Okay, right. So I'll get 374, right? 374. Check it out. Sachin,
Sir,
how much you got?
same answer, sir.
Okay. So what about others? Are you getting the same answer? 374?
Yes, sir.
Okay. So now AST minimum. Next step is you have to calculate the AST minimum and you have to compare. So what is the formula for AST minimum? For slab?
0.12% of BD, sir.
What about the 0.15%? When you are going to use 0.15%?
For mild steels.
The grade?
250 grade.
Right. So when it is 250, you are going to use 0.15. Okay. So here it is 415. So you are going to use 0.12% BD. So now check how much you are getting. So again here B is 1000 and D is 180.
$216, sir.
216. Okay. It is
Yes, sir.
okay. So it is 216 mm square. So now we have to compare with AST with AST minimum. So AST is greater than AST minimum, right? So you can consider the AST itself. Okay. So now calculate the spacing. So assuming 10 mm dia bar, you have to calculate the spacing. So small AST you have to consider. You have to assume you assume the dia, right? So here you have to consider that is pi d square by 4, pi into 10 square by 4, and capital AST is nothing but which you have calculated the reinforcement, that is 374. Okay. So check how much you are getting.
$209.77.
Okay. So you'll get 209.8 mm. Okay. So now you have to take the maximum spacing is least of the following. You have the condition, right? That is 3D, 300 and spacing which you have calculated. So among these three, so the minimum is 209 least, right? Therefore, provide 10 mm dia at 200 mm center to center with alternate venter at 1/5 to 1/7 the span of the support. Initial in the yesterday's class I have shown, right, how the alternate venter bar will look like. Are you able to understand this condition? Or you want me to show you in figure?
No, sir.
Understood?
Yes, sir.
Okay. Next, take down distribution reinforcement. Distribution reinforcement. As you know, for distribution reinforcement, you have to consider the minimum AST. So the minimum AST you have calculated is 216 mm square. So for that, here you are going to assume 8 mm diameter for distribution reinforcement. Okay. So you have to calculate the spacing, and also you have to calculate the maximum spacing. That's the least of the following. So are you getting 232?
Yes, sir.
Okay. Next, take down maximum spacing is the least of the following. So here you have the condition, one is 5D and then 450, then the spacing which you have calculated. Among these three, you have to take the least. So the least is 232. So here you are going to consider, that is providing 8 mm dia at 230 mm center to center. Okay. Any doubt in this? Is it clear for everyone?
Yes, sir.
Okay. Next, take down, check for deflection. Check for deflection. The condition is L by D provided is less than or equal to L by D permissible, which is equal to alpha into KT into KC into KF. So how much is alpha here according to the codal provision?
Twenty, sir.
Are you sure?
Yes, sir.
Okay, good. So here you have to consider 20 for simply supported. Okay. So here you have to calculate the KT value, and you know the condition Fs is equal to 0.58 Fi into EST, sorry, area of cross section of steel required divided by area of cross section of steel provided. So EST required is equal to 374.4 mm square, and EST provided you have to calculate. Okay, so this is according to the main reinforcement, not according to the distribution. That's why here we have considered 10 mm. Okay, and this is the main reinforcement spacing, 200 mm. Okay, so how much you are going to get? EST provided.
$392.6.
Okay, so you'll get 392.7 mm square. Next, percentage of steel. Percentage of steel is equal to 100 AST by BD. So how much you are getting? Percentage of steel? Hello? Chandana? Khalid?
Calculating, sir.
5.60.
How much?
5.60.
5.60. Check it out.
Yes.
So how much you have taken EST?
0.27, sir.
Huh?
0.27%.
Right. So while taking the AST, you have to consider 392.7. Okay. So it is 100 into 392.7 divided by B is 1000 and D is 145. Okay. So you'll get 0.27. Is that clear for everyone?
Yes, sir.
Yes, sir.
Okay. So now calculate FS because all the values are known. So substitute here and calculate FS. So how much you're getting FS value?
229.48.
Okay, right. So it is 229.4 Newton per mm square. Next, you have to calculate the KT value. So how much is the KT value? You have to refer the figure 4 from the code. You have PT value, that is percentage of steel is 0.27 and FS is 229. How much? Are you getting like 1.6 KT value? Okay. So you'll get around 1.65 or 1.6. Okay. So now you have to calculate L by D provided. L by D provided is equal to 3300 divided by 145. You'll get 22.48. You can just check it out.
Yes, sir. Getting.
Okay. So the condition which is less than or equal to L by D permissible, which is equal to 20 into 1.65 into 1 into 1. So you'll get how much?
33, sir.
Okay, so you'll get 33. So whether it is safe or not?
Safe, sir.
Safe. Okay. Take down. Therefore, the design of slab is safe for limit state of serviceability. So is there any doubt in understanding this problem? Is it clear for everyone?
Yes, sir.
Okay. So in the last you have to draw the detailing. Okay. So this is the plan. Okay. So these are the cross section along the shorter span and along the longer span.
Okay.
So please take down this figure. So this is, as you know, for shorter span always you have to provide the main reinforcement. So the spacing is 200 center to center, and for longer span you are going to provide the distribution reinforcement, and the spacing between one reinforcement to another is 230 mm. Okay, and this is a 10 mm is a main reinforcement and 8 mm is a distribution reinforcement. Is there any doubt in understanding this figure detailing? Is it clear for everyone?
Yes, sir.
Yes, sir.
Okay, first to write to
Yes, any doubt? Okay, please take down. Once you finish, let me know. Finished? Sindhunath? Sindhunath? Hello? Sindhunath?
sir.
And in the second internal in the Badil second internal,
ಬರ್ದಿದ್ದೀನಿ ಸರ್.
but ನನಗೆ ಸಿಕ್ಕಿಲ್ಲಲ್ಲ ಸ್ಕ್ರಿಪ್ಟ್.